What's poppin', dogs? Mr. Allen here with a video on factoring. We're going to use factoring to solve different types of equations here. I got 6 different scenarios, and we're going to do 2 to 3 examples of each one of these here throughout this video. So if you want to skip ahead to a particular one that you're like, hey man, I struggle with that one right there, feel free to do so, or watch the entire dope video and become a factoring boss. All right, let's get after it. First one here. For these 4 examples, we're going to be using what's called GCF, or greatest common factor. So for the first one here, I have 4x squared plus 8x equals 0. It's already equal to 0, so that's step number 1 if I'm going to solve by factoring. We're good there. Now I'm going to look for what's in common between these 2 terms. Well, 4 and 8 are both divisible by 4. So that's a common factor. But we also have x squared and we have x. I can take an x out of both of those. So my GCF here is going to be 4x. Now what I'm doing is I'm actually dividing out that 4x from each one of those terms. So if I divide out 4x from 4x squared, I'm left with x. And if I divide out 4x from 8x, 8 divided by 4 is 2. And I took out the entire x, so that's all we got there, equals 0. Now this is factored form. I can set my 2 factors, 4x equal to 0, and x plus 2 equal to 0. Now I'm going to solve for x. A lot of people want to subtract 4. That's not addition going on there. It's a multiplication. How do I undo that? Division. So I'm going to divide by 4, and I got x equals 0. 0 divided by 4 is 0. Don't panic and be like, what do I do? It's 0. Next one here, I'm going to subtract 2 on both sides of my equation, and I get negative 2. There's my 2 solutions for that quadratic equation right there. It's a degree of 2, should have 2 solutions. That's the fundamental theorem of algebra right there. It's pretty dope. Fundamental theorem of algebra. Okay, next one over here. Is that equal to 0? It is not. Okay, so I got to subtract that 5x on both sides. So I got 10x squared minus 5x equals 0. Right, the 10x squared and the negative 5x, those aren't like terms because one's x squared, one is x. 2 separate terms. What's my GCF? Well, this guy's divisible by 5, as is this one. And we can also take an x out of both. They both have an x to give, if you will. If I divide by 5x, which we just said is our GCF, I'm left with 2x. And then I've got minus, well, I divided by 5, right? So that's gone. I divided by x, so that's gone. Do I need anything there? Yes. I need a placeholder of 1. All right? Equals 0. And it's negative there because that was negative right there. All right? But if I take out the entire thing there with my GCF, the entire 5x, I got to have a placeholder, whether it's positive 1 or negative 1, whatever that sign is, got to have it there. Okay, that's a common mistake when factoring with a GCF. It's like lose a term. Don't lose a term. It's got to be there. Okay, now I can do the same thing. 5x equals 0. 2x minus 1 equals 0. So divide by 5 here, just like we did before, and I get x equals 0. Over here, I'm going to have to add 1 on both sides. So I got 2x equals 1. Divide by 2, almost out of space. I get x equals 1 half. So there's one solution. There's my other solution. Whee! Cool. There we go. 2 solutions. Degree of 2. Crazy. I love consistency in math. It's always very exciting, right? When you're like, hey, this kind of makes sense. All right. Next one down here. Oh my goodness. A degree of 3, bro? What are you throwing at me? Okay. 7. That's really like a 1 right here. Nothing in common there, right? But they do have an x squared I can take out. So I get x squared. And then I'll be left with, well, if I took out an x squared from here, I've got 7 still and an x left over. I'm taking out the entire x squared. Do I need anything here? Yes. We just talked about that, right? So this time I'm going to have a plus 1. That equals 0. Now I can set my 2 factors equal to 0. So I get x squared equals 0, and I get 7x plus 1 equals 0. If I square root on both sides here, that's the easiest way to solve that one, right? I get x equals plus or minus 0. Well, no, I just have x equals 0. But it is a multiplicity of 2, so technically that solution does appear twice, okay? If you were graphing these things, you'd see it like bounce off the graph. We're not doing that here. All right, this one, I'm going to subtract 1. So I got 7x equals negative 1. Divide by 7. So I got x equals, I'll just jot it over here, x equals negative 1/7. So those are my 2 unique solutions, but it's still technically 3 because this one has a multiplicity of 2, and that one. When you get into polynomials, you'll see a little more of like a multiplicity of 2. I'm not going to list it here. Those are my 2 solutions that would work here, right? But 0 happens twice. Whatever. We'll move on from that. Okay. Last one here. I'm going to go with the yellow marker, which kind of looks like this one, but whatever. It's going to be 4 different colors, okay? What do they have in common? Well, I can divide. It's already equal to 0, right? That's good. That's a win. I can divide both of these by 3 and take out an x. So I got 3x, and then I'm going to have 3x minus 5 equals 0. 9x squared divided by 3x is 3x. Negative 15x divided by 3x is negative 5. Cool. Now I can set my two factors, right, because they're just two factors, equal to 0. 3x equals 0. 3x minus 5 equals 0. This one here, easy peasy, divide by 3. Can't divide by 0. X equals 0. Yay. And then this one over here, I'm going to add 5. I get 3x equals 5. Divide by 3. And I get x equals, I'll put it over by this guy, 5/3. Hopefully we didn't run out of space. I know it's getting a little low on my board there. There we go, guys. 4 dope examples in that one. That's awesome. Going to move on to some other factoring. It's going to be dope. In these 4 examples, we're going to focus on factoring a trinomial with a lead coefficient of 1. And I know what you're saying, man. That guy's a 4 there, not a 1. What's up with that? We'll get there. We'll get there. Calm down. It's going to be okay. Let's start with example 1 here, okay? X squared plus 7x plus 10 equals 0. Step 1, you got to be equal to 0. We're good to go, man. No extra step. That guy right there, I'm going to have to do some stuff. So next thing, what multiplies to my constant here, what multiplies to that 10, and adds to 7 at the same time? What 2 numbers would do that? Well, the first thing we want to do is think about what multiplies to 10. I got 1 and 10. I got 2 and 5. Do either of those pairs add up to 7? Yes, the 2 and the 5 do. So those are the 2 numbers I'm going to use in my factors. I'm going to have x plus 2 and x plus 5 equals 0. This right here is equivalent to the green part up there. It's in factored form. Now, how can I use that to my advantage to solve? Well, if I can get either one of these 2 equal to 0, then the whole thing equals 0, because 0 times anything is 0. It's called the zero product property. So I'm going to set x plus 2 equal to 0 and x plus 5 equal to 0. And when I subtract 2 on both sides, I get x equals negative 2. Do the same thing over here. Subtract 5. I get x equals negative 5. Those are my 2 solutions. And if I plugged it into the original, I'd get 0. That's dope, man. Super dope. All right, there we go. First example, done. In the bag. All good to go. Next one. Like I said before, we got to get it equal to 0. So I'm going to add 5 on both sides. Now I'll have x squared minus 6x plus 5 equals 0. And I got to figure out what multiplies to 5 while also adding to negative 6. How am I going to get a positive, negative, what? Well, there's only 2 numbers that multiply to 5, right? It's 5 and 1. And that adds up to positive 6, but I want negative 6. What if I did negative 5 and negative 1? Because negative multiplied together gives me positive, but we'll add up to the negative 6. Bingo, bango. We got it, dog. So I got x minus 5, x minus 1 equals 0. Negative 5 times negative 1 is positive 5. Negative 5 plus negative 1 is negative 6. That's factored. If you multiplied it back out, you'd get back to that step above. Cool. Now I got to set these factors equal to 0, because if I can get one of them to equal 0, then the whole thing equals 0, right? If I can, this one here, I'm going to get x equals 5 after I add 5 to both sides. If I plugged 5 in there, I'd get 0 times 4. That's 0. I don't care about the other factor, just about the one that I got to be 0. The same goes here with the 1. X minus 1, I'm going to add 1, I get x equals positive 1. Those are my 2 solutions for that particular equation. All right, now down to the one where we were very concerned, right? We're like, bro, how's that going to work, right? It's going to work. Okay. First thing I'm going to do here, I'm going to set this equal to 0, okay? So we got 4x squared minus 8x minus 12 equals 0. Didn't have to be our first step, but I'm going to make it our first step because that's what we said all of our first steps were going to be. Consistency is key. What are all these terms divisible by? 4. Now, if we were just asked to factor this, I would take out this 4, and I'd have x squared minus 2x minus 3, all that equals 0. But because it's an equation, I can actually just divide by 4 and everything, and that 4 would be just completely gone, right? I could just divide both sides here by 4, and these 4s are gone, right? I could have done that the step above. I wanted to show the factoring, right? because some questions they just ask you to factor. But that's going to be 0. So now I have x squared minus 2x minus 3 equals 0. And now I have what I had above, right? It's as easy as the first one that we had there. Easy, I know, not that easy necessarily. Factoring is challenging because you got to think of two things at once. What multiplies to negative 3 and adds to negative 2? 3 and 1 are the only things that multiply to negative 3. And if it's going to multiply to a negative, one needs to be negative, one of them needs to be positive. Well, I'm going to want my 3 to be the negative one because I want it to add up to negative 2, right? That's going to be a positive 1 then, equals 0. Had this been a positive 2x, then the 3 would be positive, the 1 would be negative. Now I can set these equal to 0. X minus 3 equals 0. X plus 1 equals 0. Don't want to run out of room. I know I'm getting close. X equals 3. X equals negative 1. A lot of people just say like, oh, I just changed the sign. I just changed the sign. Be careful with that, with factoring, and just be like, I just flipped the sign. That's my answer. Because then you end up flipping it before you go into your factors, and you flip it again, and things get all messed up, okay? Show some steps. Show some work. Takes an extra 3 seconds, and you'll get the right answer, okay? Be careful. Cool. Last one over here. Let's see here. What color should I use this time? I feel like this one looks too similar. I'll go back to orange. I'm going to go back to, ooh, yeah, I'll go orange. I'll go purple. I'm going to go purple. Secret stash. Okay. Oh, boy. It's cute. What? How about this? GCF thing again, right? Let's do the GCF. But this time, when I take out an x, I can't divide out an x and divide by x on both sides, because then I lose a potential solution, okay? So we definitely have to leave that one as a GCF there. All right, I got x squared plus x minus 42 equals 0. Close my parentheses. This is a little squeaky. I apologize. Well, what multiplies to negative 42 and adds to 1? By the way, that x is just going to be chilling. So we're going to look like this. X, parentheses, parentheses, 0. Okay? That's what we're looking at. Ooh, numbers that multiply to 42. Negative 42. So they're going to need to be 1 apart. How about 6 and 7, right? Because positive 7 and negative 6 would add to 1. Positive 7, negative 6 multiplies to negative 42. That's it. All right, so we got x plus 7, x minus 6. Had this been a negative x, these signs, once again, would be switched. So now I've got 3 different factors, 3 solutions. It's a cubic. That means I'm going to have 3 solutions. So I'm going to have x equals 0. That one's done, right? I don't have to solve or anything. I got x plus 7 equals 0, and x minus 6 equals 0. So I'll subtract 7, and I get x equals negative 7. Add 6, and I get x equals 6. So we've got negative 7, positive 6, 0, 1 squeaky marker, but I wanted to use the purple. I mean, the purple looks pretty dope, right? I wish it came in a non-squeak format. But there we go, guys. 4 different problems there. Standard, this is like your most common factoring is the AM method or reverse FOIL. Factoring when the lead coefficient is 1. Always look out for a GCF, something you can pull out to make your life a little bit easier. Then you don't have to factor with the lead coefficient. But there we go with that one. That's pretty dope. Awesome. Moving on to factoring with the lead coefficient next. Right, if you're in the long form video here where we're doing a lot of factoring. But otherwise, have a dope day. In this one here, these 4 examples, we have lead coefficients that are greater than 1. A little more complicated, but we'll get through it. First 2 examples, I'm going to show you how to do guess and check. The second 2, I'm going to show you how to set up factor by grouping, or sometimes called the rainbow method. All right, because it helps when the numbers are even. There's a lot of possibilities going on, okay? So first one here, guess and check. Here's why I like to do guess and check for this one. You can do rainbow method if you want, but I'm going to do guess and check, okay? I know it's going to be 2 factors here, if it's factorable, equals 0. To get 2x squared, I know I have to have 2x and x. There's no other way to get 2x squared, right? The other part, I got to multiply to 7, negative 7, while adding to 5. So there's a few possibilities here, right? I'm going to show some wrong ones first and work through it so you can see the guess and check process and not just me being like, see, got around the first try. Easy. No. Let's say I do this. Let's say I do 7 and 1, right? One of them needs to be positive, one needs to be negative, okay? Well, if I've got positive 7 and I multiply these together, I get 14x. And here I'd get negative 1x. 14x, negative 1x, that's going to add to 13x. And even if I switch those signs, I get negative 13x, which isn't 5x, right? So No bueno. But let's set up another set of factors here. Again with the 2x. And again with the x, because I know that's got to be correct. But this time, let's throw the 7 here and the 1 here. I want to add to positive 5x. Well, here I'm going to get 2x. Here I'm going to get 7x. Which one of those should be positive? Which one should be negative? The 7x we want to be positive, and the negative 2x then, right? Because then I have 7x, negative 2x, that adds up to 5x. I just guessed. And I checked, and then I guessed again, and I checked, right? 2x squared, negative 7. We get 7x, negative 2x, that adds to the 5x. This is factored. We're good to go. It takes a little bit to get used to guess and check, but with practice, it is a faster method, especially when you're dealing with prime numbers, okay? Easier to go with prime numbers. This guy right here, I ain't touching this with guess and check. It's going to be a lot of work, okay? Better methods for that, in my opinion, right? And I'm making the video, so it's my opinion. Now I'm going to set these equal to 0. I got 2x plus 7 equals 0, and x minus 1 equals 0. Here I'm going to get x equals positive 1. Here I got to subtract 7, so I got 2x equals negative 7. Then divide by 2, I get x equals negative 7 halves. So those are my two solutions. Boom and boom. All right, there we go. Not too bad. Not too bad. All right, next one. So guess and check's a little trickier here because I do have an even number. There's a couple more possibilities here, right? This one, it was just 2x and x, 7 and 1, right? So we'll get it, though. We'll get it, all right? One more guess and check try here, and then we'll go to the rainbow method. All right. So I got two sets of parentheses. I know I have to have 3x and x, right? Cool. We know that's true. Now, let's think about this. If I went 2 and 2 here, let's see here, 2 and 2. Right, I usually pick the closest numbers together when possible, when applicable, right? Over here, I only had one option. So if I got 2 and 2, one of them's positive, one of them's negative, right? To get to a negative 4. Let's see which one it should be. Well, here, I'd get 6x. Here, I'd get 2x. If one of those is negative, could I get 4x when added together? Yes. I'd want this got to be negative and this one to be positive, because then I'm going to get positive 6x from these two, negative 2x from these two. 6x minus 2x gives me that 4x. That one's factored. First try, I threw the numbers in first, and then I tried placing the signs appropriately and foiling out in my head. Again, this is the toughest. It's a tougher way to factor, but it is faster when you get some practice and you're dealing with prime numbers or somewhat manageable, numbers with multiple factors, okay? So I'm going to set these guys equal to 0. 3x minus 2 equals 0. X plus 2 equals 0. I'm going to add 2, so I get 3x equals 2. Divide by 3, I get x equals 2/3. Circle it. And then over here, I'm going to get x equals negative 2. Circle it. Boom. Two solutions. Quadratic, degree of 2. It's going to have two solutions there. That's the fundamental theorem of algebra. That's dope. All right. Fundamental theorem of algebra. Sometimes I don't enunciate enough there with the big words. Okay. All right, this bad boy. This one's tough, okay? We're going to do a little side work over here, all right? So I'm going to have this little x here. And the top number here is I'm going to get from getting the 8, and I got kind of some stuff in the way there, and the 6. 8 times 6 is 48, okay? I need to multiply to that while adding to 19. What's going to do that? How about, let's see here, 48. 1 and 48, no. 2 and 24, no. Is 48 divisible by 3? Yes, it's 16. 3 and 16, both positive, are going to do that. But it's not x plus 3 and x plus 16. That's not correct. We're going to use these two to break up the 19x and set up factor by grouping. So I'm going to have 8x squared plus 3x plus 16x plus 6 equals 0. Is 3x plus 16x 19x? It certainly is. All right, so still equivalent to the one above. I'm just using an algebraic strategy to help me manage the tougher situation, okay? So I'm going to group the first two and the last two terms. These are not my factors, but I can pull out a GCF here. So GCF comes into play. Well, these both have an x in common, nothing else, and I'd be left with 8x plus 3. This one here, 8x, plus 3. Then this one over here, what would I take out of both of these? Well, this is divisible by 2, as is this. Anything bigger? No. So I'm going to have plus 2, parentheses, 8x plus 3. Holy guacamole. These two are the same. This is one big old term. This is one big old term. They have this in common. Sorry, I'm smudging. So 8x plus 3 will come out. X plus 2 is left over. Those are my two factors. And there we are. We're factored form. Just like we did before, this would have been tough with guess and check. It's doable. Just it could take quite a bit of time. If you get lucky, it's awesome. But if not, you're like, ah, right? You know? So there we go. I'm going to set these equal to 0 and finish this bad boy off. Equals 0. Equals 0. I'm going to subtract 3, divide by 8. I'm going to get x equals negative 3/8. Okay? Sorry, I'm moving a little fast there. I don't want to spend all the time on that. And then x plus 2 equals 0. Subtract 2, I get x equals negative 2. America. Beautiful. Fantastic. Last one here, dogs. I'm gonna go back to orange here in the corner. Whoop, whoop. All right. Once again, gonna do a little rainbow method, okay? So here I got 4 times negative 10. All right, I got a little x here. I'm running out of room, but, you know, I think we'll be all right. So we got negative 40, right? And I got to add the negative 3. What two numbers are going to do that? Well, we got 1 and 40. No. 2 and 20. No. 4 and 10. No. 5 and 8. There we go. So 5, 8. Which one needs to be negative there? Because it's got to multiply to a negative 40, add a negative 3. 8's going to be negative. Now I can break this negative 3x up into 5x and negative 8x. The 4x squared does not change, so 4x squared plus 5x minus 8x minus 10 equals 0. I now have 4 terms. So I'm going to group these, first 2, last 2. Make sure you bring that negative sign in there. It is important, children. All right, GCF time. I can pull out an x from each one of these. So I got x, and then I'd have 4x plus 5 left over. All right. If you don't know how to do GCF, I got GCF video as well. If you're watching the long form, skip back, baby. Skip back to the beginning. It's GCF. All right. Now, what can I take out of both of these? I can take out a negative and a 2, and I'm left with 4x. Don't forget that 4. 4x plus 5. That all equals 0. Nice. Now we have the 4x plus 5 and the 4x plus 5 in common from these two large terms here. So 4x plus 5 comes out. And then we got x minus 2 left over equals 0. Oh boy, we're going to run short on room here. 4x plus 5 equals 0. I get x equals negative 5/4. And over here I get x minus 2 equals 0. So I get x equals 2. Hopefully those all stayed in frame there. We're good. We're good. I got a little camera, not camera on here, but I can see the screen. All right. There we go, guys. That's a lot of factoring right there. That's mathematical poetry, if you will. All right, there we go. And for these 4 examples, we're going to focus on using difference of 2 squares. Let's get it. So we got to be equal to 0 in order to solve by factoring. And we are. Check. Step 1 done. All right, now if I look at these, right, 9, that's a perfect square, meaning I can square root it nicely. It's 3. Square root of x squared is x. Square root of 16 is 4. We have a difference of 2 perfect squares, so we can factor it in this way. It's going to be the same thing every time if you have a difference of 2 squares. 2 factors, they're going to look nearly identical except for one key difference. All right, I'm going to have 3x, which was the square root of 9 and the square root of x. Same with this guy here. I'm also going to have 4 and 4, the square root of 16. One is going to be positive, the other will be negative. Doesn't matter which one it is. But as we see here, we have the same 2 factors other than that key difference right there. Now I can set them equal to 0. I got 3x plus 4 equals 0. And I've got 3x minus 4 equals 0. And now I can solve for x on each one of those. So I'm going to subtract 4 on each side. I get 3x equals negative 4. And then I divide by 3. I get x equals negative 4/3. Fraction time. Love them. Then I'm going to add 4 to both sides. I get 3x equals 4. Divide by 3, I get x equals 4/3. Whoop, whoop. 2 solutions. Dunzo with the first one. A little cramped. There we go. Boom. Lovely. Awesome. Moving on. 8x squared minus 50. Oh my goodness. Neither of those are perfect squares. What in the heck am I supposed to do here, dogs? Well, what if I were to divide by a common factor. Can I divide all that by 2? I can also factor out all that by 2, right? I could do that. But since this is an equation and we're solving, I'm just going to divide by 2. And now I got 4x squared minus 25 equals 0. All right. Now I can factor using a difference of 2 squares. Woo! Lovely, equals 0. So square root of 4 is 2. Square root of x squared is x. Those are going to be the same. Square root of 25, that's 5, right? Those are my perfect squares. I'm not actually square rooting in this problem. I'm just thinking about square roots to get my 2 factors. One's positive, one's negative. Doesn't matter. It could have been flip-flopped. I got this bad boy factored, and I can solve. So I got 2x plus 5 equals 0. I'm going to get x equals negative 5 over 2. I'm going to do the 2 steps in my head there. Hopefully you follow along. Otherwise, subtract 5, then divide by 2. This one here, we got 2x minus 5 equals 0. And I get x equals positive 5 over 2. Now, you might be wondering, can't remember if I mentioned this yet, but I'll mention it again just in case. Could I just solve this using square roots? Yes, you could. But this one says by factoring, okay? So you got to follow the directions. And a lot of tests are written that way where they have it worded so you have to solve it a particular way because we want to see if you can actually solve by using square roots or by using factoring or whatever it may be. In this one, we factor in. All right, next one here. Blue. All right. Do these have a common factor? Yes. I can actually divide both sides here by 10. Ooh, this one's a little squeaky. Maybe I'll swap out. I'm going to swap out. I don't like the squeak. All right. Another blue. Okay. So I got x squared now minus 9 equals 0. And again, very tempting to use square roots. Add 9, square root both sides. But it does say by factoring. So we'll do difference of 2 squares. I'm going to have x plus 3 and x minus 3 equals 0. So set these equal to 0. X plus 3 equals 0. I get x equals negative 3. X minus 3 equals 0. I get x equals positive 3. 2 solutions. Good to go. All right, last one here. X squared equals 64. In order to solve by factoring, as tempting as it is to use square roots, I got to set it equal to 0. Yes, we know that the answer is going to be plus or minus 8. But let's also see in factoring land. All right, so subtract 64. I get, boom, 64 equals 0. And then I've got x minus 8, x plus 8. I wanted to switch it up that time and do the subtraction first and the addition second. Because I did the addition first every time. I wanted to change it up. So I got x minus 8 equals 0. X plus 8 equals 0. Add 8, I get x equals 8. Subtract 8 on both sides, I get x equals negative 8. Bingo bango. Boom diggity. Just like we thought. Plus or minus 8. Most efficient method for a lot of these is going to be solving using square roots. If we're asked to factor, it's just going to be x minus 8, x plus 8. Or over here be 3x plus 4, 3x minus 4. Sometimes we just ask you to factor and not solve. But this video is focusing on solving as well. So you get the factoring and you get the solving, right? More bang for your buck there, right? That's a valuable lesson. All right. There we go, guys. That's it for this one here. On to some more dope factoring if you're in the long form video where we're factoring like a boss. In these 4 examples that we have right here, we're going to focus on factor by grouping. And one thing you're going to notice in common with all these is they have 4 terms. That is an indicator to use factor by grouping. We also have all 4 of these already equal to 0, but if they weren't, you need to get them equal to 0 before you try to solve by factoring because you're using the zero product property. All right, enough of that. Let's get after it. We got different scenarios for each one of these here, but they all start out the same. We're going to group the first 2 terms and the last 2 terms. I always make sure to include that sign there in my second group of parentheses. Now, this looks like multiplication right now. It is not, right? I just grouped them. Okay, there's really addition between them. But I'm going to take out my GCF of these first 2 terms right away. All right, so I got x squared can come out, and I'm left with x minus 4. Next one here, I can take out a negative 9, so minus 9, and I'm left with x minus 4 when I factor out that GCF. Cool, beautiful, wonderful. So now we have 2 different terms. They're actually 2 terms, but they're really odd looking for considering them as terms, right? But they are terms, no less. They're joined together with multiplication. X minus 4 and x minus 4, those are my GCFs of each of these 2 terms. So we can take out an x minus 4 from each, which leaves behind the x squared and the minus 9 equals 0. From here, parenthesis, from here we could really set them equal to 0 and solve for x, but because we're asked to solve by factoring, I'm just going to continue factoring this thing straight through until it can't be factored anymore. So we got x minus 4, and the x squared minus 9, that's a difference of 2 squares. So I've got x minus 3 and x plus 3. And all that equals 0. Now I have 3 factors, 1, 2, 3, all equal to 0. I can set them equal to 0 and solve for x individually. So we have x minus 4 equals 0, x minus 3 equals 0, and x plus 3 equals 0. So remember, if I get any one of these 3 factors to equal 0, the entire equation equals 0, regardless of what the other 2 factors equal, right? So if I get x equals 4 here, if I were to plug 4 in, right, to all 3 of these, I'd have 0 times 1 times 7. That equals 0. I didn't even care what the other ones equaled, right? I got one of them to be 0. It all equals 0. That's the zero product property. That's why we set it equal to 0 and solve for x. It's not just some magical thing, right? There is reason behind it. So for this one here, I got to add 3, so I get x equals positive 3. And over here, I'm going to subtract 3. I get x equals negative 3. Cool. There we go. First one done. Factor by grouping. It's one of my favorites, right? One of my favorites. I don't know. They're all my favorite. Factoring is my favorite. It's my favorite F word, factoring. All right. Let us continue here. When I look at this problem right off the bat, I see all 4 of these terms are divisible by 3. So I can actually just go ahead like this. Boom. Divide by 3. Divide by 3. I can do that because it's an equation. If this was an expression and I was just asked to factor, I'd have to take that 3 out as a GCF of the entire thing. All right, but because it's an equation, I can divide by 3 on both sides. And now I just have x cubed plus 4x squared plus 2x plus 8 equals 0. And now I can go ahead and group these. I'll do that in a pink marker here. So group the first 2, group the last 2, all right? And now once again, it's just like this one, we're going to look for some GCFs, okay? What do these have in common? It's going to be x squared. And I'm left with x plus 4 this time. Over here, I can take out a 2, a positive 2, and I've got x plus 4 equals 0. All right. So now we got our GCF here, and here is going to be x plus 4. They have that in common, so I take that out. If you're not recognizing that as a GCF, it's not the end of the world. That is mathematically what's happening there, but usually we just see like, okay, these two are the same. Boom, that's one of our factors. The leftovers, that's another factor, all right? So now I got this thing factored. Can I factor this any further? No. If it was a difference of 2 squares, like we had over here, then I could. But this one cannot be factored across the set of real numbers, right? You can do it across a set of imaginary numbers, and it's a little odd. We'll get there another day, all right? So I'm going to take x plus 4, set it equal to 0, x squared plus 2, and I'll set that equal to 0. This one's easy to solve. I get x equals negative 4. This one will take a little bit more work. Work, like Rihanna. Okay. I'm going to subtract 2. I get x squared equals negative 2. Then I'm going to square root on both sides, right? So I will get, I'll put it right here, x equals plus or minus, right? We got to have the plus or minus when we're using square roots to solve, right? I got to account for both solutions there. If I was just simplifying a radical, it just is what it is. When I'm solving using square roots, I have to account for both the positive and negative possibilities there, okay? And then a negative inside the square root. An I needs to come out here, right? That's how I deal with a negative in the square root. And I cannot break down the square root of 2, so it just stays square root of 2. So a little bit of fuss there on that one, but not too bad overall. We've got 1, 2, 3 solutions there. It is a cubic equation here, so we should have 3 solutions according to our fundamental theorem of algebra. The degree matches the number of solutions. Sometimes those solutions are the same, right? We could have like x equals 3 and x equals 3. It still has 2 of those, but they're not unique, okay? So, lovely, fantastic, and wonderful. All right, I'm going to go blue marker this time, okay? Next one. Whew, it's a lot of factoring, man. It's tiring. Hopefully you're sticking with me here. I appreciate it if you are, okay? So here, I can't divide everything by the same number, so I'll just go straight up to the grouping portion here. Boom, lovely, right? We got GCF of 4x squared this time. Cool. And I'm left with x minus 2, and then we got plus 7, and we got x minus 2. All that equals 0. Awesome. All right, next bit. GCF here and here. That comes out. I get x minus 2, leaving me with 4x squared plus 7 equals 0. So that 4x squared plus 7 cannot be factored, right? So I'm at the point like this one here where I'm just going to set this stuff equal to 0. We get x minus 2 equals 0, so x equals 2. Easy. All right, this one here is going to be a little bit more complicated, which is exciting, right? Let's subtract 7. I get 4x squared equals negative 7. Let's divide by 4. I get x squared equals negative 7 over 4. Now, I'm going to go ahead and square root on both sides. Okay, this is where the fun begins. I'm going to pop over here and work this way. Okay, so we're going to have x equals, we've got plus or minus, right? I have a negative in there, so I'm going to pull an I out. And I'm going to write this with a square root in the numerator, which is 7, and a square root in the denominator, which is 4. Because now we can see, oh, I just had the square root of 4, right? You can individually square root each one of these. That is legal, okay? You can write it over the whole fraction, but because I'm looking ahead, I'm seeing, okay, that's going to be a 2. So then we're going to have plus or minus I, and then it's root 7 over 2. Whoop, 2. All right, last one, dogs. First thing I'm going to do is I'm going to check to see if we have a GCF between all 4 of those terms. I do not, so I'm just going to group the first 2, the last 2. Always keep that sign of the first term of the second group there. Keep that sign in there because we are going to take that negative out with it every single time. All right, so GCF in the first 2. I can divide that by 4 and by x squared. So we can take a 4x squared out, leaving me with 2x plus 3. And then here I can just take out a negative 1 from each one of those. So minus 1, and then we got 2x plus 3. All that equals 0. So there we go. We got the GCF, right, the common factor there between each of those terms. So I'm going to take out the 2x plus 3, and then I'm left with 4x squared minus 1 equals 0. Woo! We haven't seen one of these in a while, man. We got a difference of 2 squares. I can break that down further. So we got 2x plus 3 times 2x minus 1 and 2x plus 1 equals 0. So difference of 2 squares is very common to come up when we're doing factor by grouping. So always look for the difference of 2 squares to see if you can break it down further, especially if they're just asking you to factor it. If we were just asked to factor, that's our answer. Because we're asked to solve, I got to set each factor equal to 0. So 2x plus 3 equals 0, 2x minus 1 equals 0, and 2x plus 1 equals 0. So over here, I'm going to have, let's see here, 2x equals negative 3, so x equals negative 3 over 2. There's one solution. Then we got 2x equals 1, so x equals 1/2. It's another solution. And then 2x equals negative 1, so x is going to equal negative 1/2. Woo! And if I were to set the 4x squared minus 1 equal to 0, use square roots to solve, I would have gotten plus or minus the square root of 1/4, which is plus or minus 1/2. So there we go. We get the same solutions regardless of how we did it. You could have set this equal to 0 afterwards. I think that's fine. But because we said by factoring, I just wanted to factor until I could not factor no mo. And for these 4 examples here, we've got degrees of 4. Oh my goodness. And some lead coefficients. Holy guacamole. But you may notice these are all trinomials. They're already equal to 0. That's a plus right there, right? But we can actually factor them using the same kind of strategy we would for a quadratic trinomial. Okay, so check this out. First one, all right, what multiplies to negative 18 and adds to 3? That would be 6 and negative 3. So my factors are going to look very, very similar to what I would normally do for a quadratic trinomial. I'm going to have my positive 6, and I'll have my negative 3, okay? But instead of x and x, I'm going to have x squared and x squared. There we go. So x squared times x squared, that's x to the 4th. Negative 3 times 6, that's negative 18. 6x squared, negative 3x squared, adds to 3x squared. Boom, diggity, dope, awesome. All right, so we are factoring using essentially quadratic form, some people refer to it as, okay? Same strategies as a quadratic trinomial, just with a degree of 4. We got this. All right, so can I factor any further here? No. I'm going to set each factor equal to 0 now. X squared minus 3 equals 0, and x squared plus 6 equals 0. So if I add 3, I get x squared equals 3. Square root on both sides to solve, and I get x equals plus or minus the square root of 3. I can't simplify the square root of 3. That's it. We're done with that one right there. Next one right over here, I got to subtract 6. I get x squared equals a negative 6. Square root on both sides, just like I did, and I'm going to get x equals plus or minus. What happens with the negative in the square root? Take an I out, right? Imaginary number, root 6. I can't break down the square root of 6, so that is what it is. And I've got 1, 2, 3, 4 solutions here. It's a degree of 4. That is the fundamental theorem of algebra right there. In action, dogs. Degree of 4, 4 solutions. They might not be 4 unique solutions, but 4 solutions no less. 2 real, 2 imaginary. Awesome. All right. Next one here. Once again, think of it in quadratic form, right? Like a trinomial, a quadratic trinomial, what multiplies to 4 adds to -5. That'd be -4 and -1. So we can factor it the same way, except we got x squared minus 4 and x squared minus 1 as our two factors instead of x minus 4 and x minus 1. Awesome. All right. It's always great to be able to relate back to old math concepts to help you solve new math problems. All right. That's a common practice here in mathematics, even though sometimes it doesn't seem like it's similar, right? We are trying to pull from prior knowledge and apply it here to make our life a little bit easier. Can we factor these? Yes, we can factor this one. It's going to be x minus 2, x plus 2. Can I factor that one? Heck yeah. X minus 1, x plus 1. Could I have also just set those two equal to 0, solve using square roots? Absolutely. Because I put in the directions solve by factoring, I figure let's factor this thing all the way through and solve it. If we just asked you to factor the trinomial there, that's my answer. But we are solving, so we're going to set each one of these equal to 0. X minus 2 equals 0, so x equals 2. X plus 2 equals 0, so x equals -2. X minus 1 equals 0, so x is going to equal +1. And x plus 1 equals 0, so I get x equals -1. 4 dope solutions. You could also write it as x equals ±2, x equals ±1 if you want to save a little bit of time. All right, there we go, guys. Nice work so far. Nice work. I guess I'm complimenting myself in that video, but I bet you guys are doing great work too. Okay, I can't see right now. I can feel it. Okay, you guys are doing great work. Okay, let's move on. Oh boy, lead coefficient. Nobody likes factoring with a lead coefficient when it's a trinomial because it can be kind of a pain. But all right, I like to use guess and check when I'm dealing with prime numbers or very manageable numbers. So we're going to go guess and check style. If you wanted to break this apart and do factor by grouping, aka rainbow method, you're more than welcome. But I'm going to show with factor by grouping. I'm going to show with guess and check here, okay? So I know I'm going to have my two factors. I know the only way to get 2x to the fourth is 2x squared and x squared, or vice versa. How do I get 5, right? Well, that's 1 and 5 or 5 and 1 for multiplication, right? So if I were to put 5 here and 1 here, I'd get 5x squared and 2x squared. That adds to 7x squared, not 11x squared. Whoops, let me move my markers. Okay. If I flip-flop it, I put 5 here and 1 here, I'd get 10x squared, 1x squared. That adds to 11x squared. That's our winning ticket right there. Awesome. All right, so can I factor any further? Not a difference of 2 squares, not a difference of 2 squares. Not going to be able to factor this thing any further. It's time to set equal to 0 and solve. And oh boy, it's looking like we're going to have some imaginary solutions on this one because I'm going to have some square roots of some negatives here, man. Get ready to enter imagination land. Okay, we're going to subtract 1 and divide by 2. I'm going to do that in one step here because we're going to be taking a little bit of room for some work. So x squared equals -1/2 square root on both sides here. And I'm going to get x equals plus or minus. We're going to take I out, right? If there's a negative inside the square root, we could take I out. In the numerator, I'm going to write this with 2 different square roots. You can write it as square root of the entire 1/2, but I'm going to write it with 2 separates just to see the math a little bit easier, in my opinion. That's going to be a 2 right there. All right, that's a terrible looking 2, and I'm making it worse. Okay, so square root of 1 is just 1, right? So we got x squared, x equals plus or minus I. We've got 1 over root 2. Root 2. Can I leave it like that? Am I allowed to have a square root in my denominator? No. Some old dude a million years ago said no square roots in the denominator, and we've decided to continue doing that. I don't know why. There's no point. But it's mathematical law for some reason. Okay, so I'm going to rationalize. Multiply by root 2 over root 2. And my final here is x equals plus or minus I. 1 times root 2 is root 2. Root 2 times root 2 is just 2. Boom. Dope. There we go. It's awesome. It's fantastic and wonderful. All right. Next one over here. Not as bad. No fraction this time. We got x squared equals -5. Square root on both sides. I get x equals plus or minus I root 5. That was a nice break after that one. That was a beast over in this area here. But nice work. Awesome. Fantastic. Let's do one more. One more. All right. So, once again, I got a lead coefficient in this one. Terrifying, right? And it's an even number. This is not a prime number over here, right? We got 1 and 4, 4 and 1, 2 and 2. That can all make that, right? But the 3 It's 1 and 3, 3 and 1. One of those needs to be negative. One needs to be positive. I think we can still do this with guess and check. And I'm going to show you my strategy. So I got my two factors here, right? Equals 0. I start with the two closest factors. 2x and 2x are numerically closer than 1x and 4x, okay? It's not going to work every time. That's how I start these, okay? And then I start moving further apart. It seems to be that the closer ones together are the ones that frequent the factoring land more often, okay? So now I'm going to have 3 and 1, 1 and 3. Now, does it matter where I place the 1 and the 3? No, because it will multiply out the same. This is going to give me 6x, squared and squared. Woo! This is going to give me 6x squared. This is going to give me 2x squared, right? So either way we slice it there, 3 and 1, 1 and 3, it's going to multiply out the same. So now we can just focus on our negative and positive. 6x squared, 2x squared. If 1 is negative and 1 is positive, could that add to 4x squared? Yes. If my 6x squared is positive and my 2x squared is negative, we're money. There we go. So we got this thing factored. Now we can set them equal to 0 and solve. So I've got 2x squared minus 1 equals 0. So we got x squared equals positive 1/2. Square root on both sides. I'm going to get x equals plus or minus the square root of 1/2. Now, if we think back over here, remember we had 1 over root 2, and I rationalized by doing root 2 over root 2, and we get x equals plus or minus root 2 over 2. That one, the root 2 over 2 is a common one that comes up in trigonometry. Okay, so you'll be seeing 1 over root 2 and rationalizing that quite frequently in mathematics. All right, next one here. We got ourselves 2x cubed plus 3 equals 0. So I'm going to have x, what does it say cubed? Squared. All right, so 2x squared plus 3 equals 0. I'm going to subtract 3, divide by 2. I'm going to get negative 3 over 2. And then I'm going to square root on both sides. So I'm going to get x equals plus or minus. It's a negative in there, so I. And then we have root 3 over root 2. Okay, again, I like to separate those because then it reminds me of how I want to rationalize and things like that. I need to multiply by the square root of 2. But the square root that's in the denominator is what I'm multiplying by. So we're going to do that. Root 2 over root 2 there. Why can I multiply by root 2 over root 2? That's a good question. Well, anything divided by itself is 1. And multiplying anything by 1 is itself. So we're really not changing the answer here. It's going to look different, but it is equivalent, okay? So that's important when we talk about, multiplying by a creative form of 1, as they sometimes say. All right, so we got x equals plus or minus I, and then we got 3 times 2, that's root 6, over root 2 times root 2 is root 4, which is 2. Boom. There we go. There we go. 4 answers, 2 imaginary, 2 reals. Some dope stuff right here, guys. All right, that's awesome, man. There we go. So we got some factoring, solving by factoring. There's a ton of factoring there. If you're watching the long form here, you've made it all the way through this bad boy right now with all the factoring. It's probably going to be like 30, 40, 45 minutes. I don't even know how long. Thank you guys for tuning in here and joining in all the factoring fun. And if it was just this one that you're watching right here, pop back, man. There's tons more factoring to go on the Mr. Allen Math channel. So like, subscribe, math, YouTube. Awesome.